Thank you, Mr. William Blackock, for the wonderful exposition on a subject which I really love. I think you would have seen in the comments that on the 8th of March 1870, Bombay and Calcutta had also met with the same golden spike being placed in Jabalpur. It was a wonderful session. Thank you, Mani, for I mean, conducting it so well. Now we have a totally different topic. It is about the 100 glorious years of railway electrification. The speaker is Dr. Jaideep Gupta. The moderator is our very active Secretary of the RES, Mr. JL Singh, a mechanical engineer by qualification and a railwayman by profession. Nevertheless, JL Singh's first love is rail enthusiasm. Having spent a lifetime in the railways, he has now retired from active service, but not from the railway world. One of the Rail Enthusiast Society's founder members, he is
He is
he is secretary.
secretary.
Somebody has put
Somebody
on.
has put on.
Please carry on, Manoj.
Okay. He is secretary and also the editor of its quarterly magazine. As part of his work with the Indian Railways and Rights Limited, he has travelled widely and worked with the railways and rail related areas in India and all continents except Antarctica, giving him a comprehensive picture of rail activity and rail enthusiasm the world over. Over to you, Mr. Singh.
Thank you, Manoj. In India, the 3rd of February 1925 is a very significant date with regard to the railways. That is the day when the first electric-powered train ran from what is now Chhatrapati Shivaji Maharaj terminus in Mumbai and ran up to Kurla along the present harbour line. That was exactly 100 years back. So this year we are celebrating the 100th anniversary of rail electrification in India. There is no better person to tell you about this than Dr. Jaideep Gupta, who is the current additional member Railway Electrification in the Indian Railway Board. Dr. Gupta is an electrical engineer by qualification, but he has been a regular professional railwayman since 1988. Dr. Gupta is also a MTech and PhD in artificial intelligence technology with specialization in electrical machines and drives. In a career spanning over 3 decades, he has shouldered several key assignments in the Indian Railways, which include that of Dean of the Indian Railways Institute of Electrical Engineering at Nashik, Additional General Manager of the Eastern Railway Zone, as well as its Principal Chief Electrical Engineer and Principal Chief Safety Officer. He has served as Divisional Railway Manager of the Sambalpur Division of the East Coast Railway Zone. Other assignments include 2 training stints, one in Italy and one in Singapore. It is interesting to note that during his tenure as Principal Chief Electrical Engineer of the Eastern Railway Zone, that zone achieved 100% electrification of its network. So over to you, Dr. Gupta. Dr. Gupta, over to you.
Yes, good afternoon. Good afternoon, Mr. Jail Singh. Am I audible?
Yes, you are.
Okay, thank you. Respected seniors, because I find a lot of my senior bosses also in this group, and dear rail fans. It's a pleasure and a privilege to be with you all in this Sunday lovely afternoon, discussing about the 100 years of rail electrification. But before I start with my presentation, I'll start with a small couplet which I read somewhere. कि मैं भी तू भी यात्री आती जाती रेल अपने अपने गांव तक सबका सबसे मेल. Loosely translates that we all are travelers in this train type life. Until our destination, we are together in a meeting discussing things. So, friends, 2025 is a very landmark year for the 2 important reasons, as Mr. Singh has just also said. The first electric train on the Indian subcontinent ran on 3rd of February 1925, just exactly 100 years back, from Mumbai to Kurla. And also 2025 is a year when Indian Railways is going to be 100% electrified. 100% electrified means over 68,000 route kilometers, over 1.5 lakhs track kilometers, fully electrified. I'll be sharing the details also in my later presentation. And if you want more details, you can go in the Indian Railways February edition, which has my article also on this subject. And uh, that article also says about the different status of the rail electrification in different railways and the different states. So, what I'll do, I'll take you through the entire journey of 100 years. In fact, I asked most of the rail fans what you want me to speak, and they almost all of them told me that it should be less of technical, more of pictures, photos, anecdotes. So I'll try to restrict myself in more of pictures because that is going to be more interesting. I like that this presentation may be interactive. I mean, you can raise your hands, you can interrupt me, and I'll be too happy to reply to your different questions or different topics.
If I'm allowed to interject at this stage, I request
Yeah.
all participants to write their questions in the chat box and not ask them directly. Put them in the chat box, and then I will go through them and ask Dr. Gupta. Thank you.
Okay. Okay. Thank you for the clarification.
Go ahead, Dr. Gupta.
Yes. Yes. So this is the Indian Railway journey. The beginning, as you all know, and then as we progressed, steam engines came, diesel locomotives in 1867, then DC locomotives, three-phase, Vande Bharat, and 100 years now the railway has progressed. And since no other railway in the entire world is having so much experience of electrification, like no other country has so much of electrification, like 1.5 track kilometers of OHE. So we are the global leaders of electrification, and the Indian Railways engineers are the perhaps the best in the world to lead the electrification of the entire world. Because as you know, uh, the climate change is a very important issue, and all of us together have to act, should act to see that the fossil fuels, the greenhouse gases, should be restricted, and more and more fuel should be used which does not impact the climate, and that is electrification is one of the important uh, aspect of doing this. So India's first electric train ran between Bombay VT and Kurla, and the section was 1500 volt DC that time. In fact, initially the suburban traffic used to run on the steam engine, but very soon people understood that if the Bombay suburban was to cater so many of passengers in such a small suburbs, like all these stations were so close by, so there has to be a system which has a massive acceleration. And so steam engine, because by that time the IC engines have not yet developed too much. So if more acceleration was required, the electric traction was the only solution, and that's why it was rightly decided by then all our visionaries that we have to go for electrification. And since that time, AC was there was no technology advancement of the even the rectification, how to rectify AC to DC, and people knew that traction only DC motors can be good in traction, because the DC series motor जो traction curve is there, which is very uh, suitable for the traction applications. So it was decided, and that was the only solution that time people were aware कि we should have a DC 15,000 volts, and then again we'll bring down the voltage and supply to the DC series motor, and then that is the only way of increasing the speed acceleration of the suburban trains, so to cater with the growing demand of the local public. Siemens and AEG initially supplied the electric locomotives. Suburban train services in Mumbai became the first electric rail operation. Electrification was primarily focused on improving city transport. That was the initial point. The initial success led to the further extension plans. Then in 1832, the proposal to construct the first railway line in India at Madras was made. Then Then, of course, Madras and Calcutta area was also very advanced, and there was a lot of suburban requirement. So, in 1835, railway track was constructed in the southern Chennai area, Madras area, between Red Hills and Chintagdripet in Madras, and became operational in 1837. It was hauled by a rotary steam engine, as I just said. Then the Madras Railway was till 1845, and the Great Indian Peninsula Railway was in 1849. Temporary railway lines were built, such as the railway line of Dhobaleshwaram, built by Arthur Cotton. And as you know, the Roorkee, even in the north, when they in the Roorkee also, there was a uh, start of a train to haul the stones in 1851. The first step forward was taken in 1925 when the first electric passenger train in India with 1500 volt DC started between Victoria and Korla Harbour, 3rd February 1925. The VT section was electrified with an elevated platform Sanders Road. And then, as for the carts also, it was decided that there was no other option but to go for electrification, because they have to cater to the steep gradients. Then in 1928, the Western Railway, that was the BBNCI of that time, that also started in January 1928. So this is the photograph of the initial suburban train, which is hauled by a steam loco used for service about the city of Bombay. And as I was just mentioning, that the steam locos were not very suitable in the suburban operation. So, and this is the old photograph of an basic electric loco. Because of the elimination of the boilers and of the uh, generation of steam, the turbines, this became very light. And since the energy was not constrained by the boiler capacity, so any amount of energy can be taken from the pantograph. It's a very elementary pantograph, and there's a very small resistance sort of notch controller. So this was the basic locomotive design initially thought of. Here I like to point out, and I like to read also, because it's a very visionary statement. The governor of Bombay, during the inauguration of the first steam train, he has said this quote: "Great enterprises often start from small beginnings, and although the length of line which is now inaugurated is only 10 miles, that was 16 kilometers roughly, the significance of the change from the ordinary steam engine to the modern method of electric traction must strike the imagination of the least imaginative amongst all." It's a very imaginary statement. I mean, say it's 100 years old statement, but such an imaginary one. It was further said that this is the first line of electrified railway in India, and as usual, Bombay is giving lead to other parts of this country in the matter of communications, as it did about 100 years ago. 100 years means he's mentioning about the first railway train, which was again started in Bombay around 100 years back. The city of Bombay was the second largest economically and strategic important city, and so these were the opening statement of the governor's speech, and it says the vision of those people that time and how this electrification started in our Indian subcontinent. This is a picture of a initial EMU motor coach, and notice the diamond pantographs, because that time the Fevoli type single pantographs were not invented, and people thought key balancing would be very important in this. So that time the diamond pantographs were used, and this continued to be used in DC for a very long time, even recently till 1980-85. This again is the clip of the newspaper which carried the story of the first train, electric train in Bombay from Times of India. And this somewhere I've got it from somewhere that like the British Parliament, which passed the Cheap Train Act in 1990, the Bombay Municipal Council passed a resolution making it obligatory in the two railways to electrify upon Kalyan and Virar respectively. And the inspiration came from London Railway, which was electrified in 1890. So London Railway was electrified in 1890, and perhaps because of the heavy smoke also, perhaps people must have thought that at least in Mumbai suburban section up to Kalyan and Virar, the electrification should be obligatory. So it is a road to electrification. 1825, Operation India 1853. The first electric passenger train in the world was 1879. And a few benefits of electric traction over other traction, that high power, acceleration and efficiency. Electric locomotives require less maintenance, no pollution, capable of hauling longer, heavier trains over steep inclines, and boon for suburban traffic. This is an old photograph of Sanders Road, which you all know, you must have seen also whenever, especially the Bombay persons. Every day you have to see this, every day you will pass over this. This is Sanders elevated railway station. And it's a slightly after photograph, maybe after 10 years of this photograph. It's a train, old electric train passing over the Sanders Road elevation. It's just a picture of a old DCMU, which you all must have seen. Uh, with the electrification of Mumbai, even southern India didn't lay back, was not much back. Madras Beach to Tambaram line was inaugurated with 15,100 volts DC again. Few meter gauge lines were ever electrified in. This was the only meter gauge line which was electrified in India. And then in eastern also, Howrah to Sierrafulli in December 1957. This again is a heavy density route for suburban traffic. And here by that time, people thought of because by that time there was experience that 1500 volts, perhaps the cable conductors were too big, too heavy to carry that much of power. So they tried to double the voltage so that current can be reduced to half for the same amount of power to be flown. So this was 3000 volt DC was used in eastern India, and first ever 25 kV system also came in 1957 in the eastern part of the India. That was in Chakradharpur Division, now it's CKP Division. That was between Rajkharaswa and Dangaposi. And that was India is the second country after Soviet Union to do so. Incidentally, I like to say that when 3000 volt DC was made in eastern India, it was by that time there was a decision that we'll be switching to AC 25 kV, and that's why most of the eastern railway electrification was carried with the thought that we'll be converting 25 kV AC, and that's why the clearance in Calcutta area was that of a 25 kV AC, and that's why it became much easier to shift from DC to AC in eastern part, then converting it to in Mumbai part, and that's the reason Mumbai remained DC for such a long time. It's a WCM1 locomotive, very beautiful locomotive. Old people must have seen it. It used to all the prestigious trains of the Central Railway, the erstwhile GIP. It's the old photograph of a EMU. It's the just a slide of beginning of RE in Indian Railways. First of 30th November 1959, first Indian Railway AC locomotive WM1, then designated as BBMI number 2250, arrived in India. I'll be showing few photographs also of this in my later presentation. This is about the DC traction in the Western Railway. Electrification of Borivali Virar section 1935 compared to June 8, 1936. Electrification was implemented with power by Tata Sons Hydroelectric Power Supply Company. The power was this should be 1500 volts. I don't know why this slide was saying 2000 to voltage. Maybe the power was 2000 volts distributed a voltage of 15 through overhead lines. Incidentally, you must be aware that in the BBCI Western Railway, the changeover was dynamic. That is, the train used to, during the run only, the train used to take the changeover from DC to AC just after Virar. And in Central Railway, there used to be a changeover, static loco changeover at Igatpuri. Then changeover AC traction, it was all decided that we'll be shifting to 25 kV. Core was created, Center of Rail Electrification. And then finally, our visionary engineers have decided, taking the cue from the SNCF, that 25 kV, 50 cycles is the solution for the Indian Railways requirement, and which continued to serve us for such a long period till today, even further. And now we are going for 225 kV, which I will be coming afterwards in my presentation. It's a first EMU motor coach of 1925, and this is a BBNCI Western Railway EMU of 1952. This is a locomotive which was used in South Indian Railway in the meter gauge section from Madras to Tambaram in 1929. This was a Bobo locomotive, and this was from Messrs. English Electric Company. This is a very beautiful. This is a meter gauge electric train used in Madras urban trains. I have been fortunate to footplate in this meter gauge, even in this EMU and YAM1 during my probation days. And it used to look very good because we are used to seeing PG electric locomotives in Bombay and Calcutta area. So Chennai, when we used to see this small trains, it used to be very interesting to see. And when we had used to enter the cabs, also used to feel the small, but it was very powerful. YM1 I have seen was very powerful train, and the cab was also much spacious than the WM1 during that time. Of course, now the cabs are much better of three-phase locomotives and Vande Bharat. The cab is very spacious, and we have come a very long way in improving the conditions of our loco pilots since then. This is a photograph of Kumar Dubey feeding post, 10th August 1960. WAM1 in the background. These are the few locomotives. I'll just mention the few that this was WCG1. Note it's having a connecting rod also, and this connecting rod is the limitation for the higher speeds. But that was the only technology available that time. Perhaps they thought that motor has to be. They were not aware of the individual driven motors, so they wanted that there should be one motor and the traction should be distributed to other wheels through the connecting rods to avoid the slippage. So, but that again was the limiting factor because connecting rod cannot allow speed of higher potential. And this is WCM1 between 1954 and 55. This is 3170 HP. Then came the WM1s, and then WAG1. This is a goods locomotive. Between 1963 and 1968 it was manufactured, and then the WM4, the workhorse for many days of 3640 HP, and further this got advanced to WAP1 as we wanted more coaching higher speeds. So WM4's gear ratio was changed, and slight motors were improved, increased, and the front was made aerodynamic, and the speeds were further increased by WAP1. WAG5 was went very well. It was a beautiful, wonderful loco, very reliable loco, and now since I have maintained these locos for such a long period, I find maybe because we were so tuned to maintaining these locomotives, we understood everything about this, and we feel very confident of troubleshooting and for maintaining these locomotives, WG5 and WG7. These locomotives and WM4. These locomotives, perhaps during our time, it used to be the workhorse, and that is the reason uh, we love these locomotives. And even now, we know the circuit so well that we feel these are the most robust, most reliable locomotives, and they worked very well. Even today, they are working and giving a very good performance. Then came the three-phase locomotives. Then it was decided, then the technology came that DC series motor, of course, having inherent advantages of the characteristics which is suitable for the traction applications, but it is having certain problems like the carbon brushes, commutator, and that's why the maintenance is much more. Secondly, the regenerative actions application is difficult in a DC series motor. And since the advent of the thyristors, power electronics, it was decided that why not have a three-phase locomotives. Induction motors, three-phase induction motors are the most rugged, and the only problem was the controlling the speed. And since now the firing angle was within our range, the thyristors were within our range, we knew how to control the voltage, how to play with the voltage and the frequency. So that's why the VVVF, variable voltage, variable frequency, came into force. And now the induction motors are as good as DC series motor, even much better in traction applications. And then since 1993, we have started these three-phase locomotives, three-phase induction motors, traction applications. And in this, of course, 25 kV remained the same. AC was taken from single phase AC, 50 hertz was taken from the pantograph. There used to be a DC link, first rectification to DC, and then the DC link used to go to a three-phase inverter, and these inverters used to produce the three-phase AC power, a variable voltage, variable frequency power, which used to be fed to the induction motors. And accordingly, we had a wide range of traction control, torque control, as well as the speed control, right from zero to the high maximum speed. It's a photo of Memu, and it's a WAP4 locomotive. It's a wonderful loco again, very reliable, very easy to maintain, 5000 HP. Is used to haul number of mail express passenger trains, and most of us must have been on trains hauled by these trains and these locomotives. And it's a WAG9, 6000 HP, again three phase, and it's a passenger version is WAP7, 2000 onwards, 6350 HP. Then came WAG11, further advancement, WAG12. So in this way, the locomotives advanced, but 25 kV remained 25. Of course, the internal afterwards, because changing OH is very difficult. Once the OH is made, the entire traction system is made. It's very difficult to change it. So that remained the same, and that will remain the same. But the locomotives, the internal structure, the internal configuration changed as the technology improved and as the demand increased. This is a beautiful loco, as I used to haul the Deccan Queen WCM1 locomotive of the same color scheme as the Deccan Queen during that time. Again, a different view. This is a blue colored loco. Yeah, it's a WCG2. Most of the Bombay people must have seen it. It used to run the freight trains and also the bankers. The bankers, just a minute, I'll just go through your remarks, because that will give me the way I'll go through the chats, just a minute, and then I can change my this thing also if required. Okay, so this was WCG2, and this used to be always used to see triplet, like the three locomotives as a banker, For goods train, there were 3 locos to bank, and for coaching, even 2 was allowed, 2 can bank, but since for flexibility, always 3 locomotives were kept as triplet in Igatpuri and Kasara Ghat section. And you must have heard lot of noise coming from the rheostats of the cooling blowers of because it's a DC locomotive, so the entire voltage, if the voltage has to be decreased, the current has to be dissipated in a resistance because there's no other way. So for that, there has to be heavy blowers. So you must have seen, because I have a number of times when I was in Igatpuri over the hills, these locomotives used to give a very big sound. All the in the night, the entire hill used to reverberate with this sound of WCG2 blowers. You must have also experienced this. So this was a WCG2 DC bankers locomotive. And now I'll go to the next slide. This again WM1, very cute looking locomotive, but during its time it was a very powerful locomotive. The cab was very spacious. I mean, as compared to the locomotive, the cab was very much spacious. And during my Western Railway days, when I was in the operations in Baroda and as AE and D, that time this loco used to haul the trains in the Bombay, Ahmedabad, Bombay, Baroda region. And number of times I footplated and even tried to, I driven also a few of these trains in this loco. But the loco was very good, very wonderful locomotive. And it's a uh, Indrani Express anniversary train. That's a photograph. It's again a photograph of EMU. It's a WCG2 in the trip set. And see the wonderful photo. This is of the either of the Kasara or of the Karjat. I like the my Bombay fans to tell whether it's Kasara or Karjat. I'm not able to know, but anyway, it's one of those. And so many locomotives bank ready to bank the train upward. It's a uh, map of the GIP, old map of GIP and the BBCI Suburban. Again, a different view of WCG banking locomotives ready to bank the trains uphill. Is Southern Railways YM1 class locomotive I was just mentioning. It's a small, very cute locomotive. It used to take the Vaigai Express and the Pallavan Express between Egmore and Vellupuram, and perhaps Tambaram or Vellupuram, because I have footprinted to Tambaram number of times. It's a chopper controlled local train. Again, with the advent of thyristors, it was decided, as I was just mentioning, because there is no way of changing the voltage. Either you have to dissipate voltage through a resistance, and again, that is a waste, and then blowing the heat of the resistance. So it is a better thing. A chopper is a much better, because in this way, we can on and off the circuit, and the voltage can be controlled without the use of dissipating the energy. So this came somewhere in 1980, that we can have a DC current which can be chopped off and on as per our demand, and then we can have an average voltage which can be varied by controlling the firing angle. So this was used initial days of our thyristor control, and chopper controlled EMUs, chopper controlled locomotives were also made. Is a photograph of a electric suburban. It's again photos of few locomotives. It's a switchgear of a 1500-volt DC substation. I worked in this area in Bombay Suburban during the initial days. Of course, this was very big, but it was very big, used lot of space. And one of the biggest problem was fire in this, because if there is some problem, The DC cannot be quenched very easily. AC has an inherent advantage of quenching the fire because every time the cycle goes through zero. And we have around 50 times, 50 occasions when we can control we can control, interrupt the arc when it is at near zero. But in DC, since it's always continuous, once fire starts, it's very difficult to open the circuit because there's a lot of sparking in this. I have seen, because of lizards and rats, lot of fires happening in these switch gears. And the reason was such a small thing like rats or lizards entering the bus bar. And once the fire used to start, all the switchgear used to burn, and the entire substation used to be off. And then we used to extend from both the sides for a very long time. I remember during Bombay days, all suburban trains were told not to go in parallel between Marine Lines and Churchgate, between Grant Road and Churchgate, because there was one traction substation which was not in service because of fire. And then because of overcurrent, it used to trip. So all the trains used to run in series only after Grant Road up to Churchgate. So those were the days. Things have improved since those days till now. Now we are so much sufficient and so much aware of the technology that these restrictions are no longer a subject matter. This is again a locomotive of TC, and this is this is a locomotive made by BHEL. This is a, central loco. It's a WCM 3 locomotive. It's an AC/DC locomotive used in Western Railway, having two pantographs, one of DC and one of AC. And after Virar, the train used to run, and he used to change the DC to AC and change the pantograph also. This was made by the Bharat Heavy Electricals Limited. It's also a wonderful loco. Very, very. Even today, it is running. Even today, it's running. Few of the locomotives have not completed their life, so it's being asked to run for a few more years. It's a Shatabdi color train. That's a WCM Shatabdi color livery train, which is matching the Shatabdi train. And again, this is a EMU. This is a WCG locomotive, and this is the initial when the EMUs came to India. It came via the ships, and it's offloaded in the Majigaon dock. And this upper photo is about it's taken from a movie. It shows the diamond pantograph. It's again the Sanders Road bridge, and this is the different angle photographs of the suburban train to you to see and enjoy the beauty. Is the catenary span 120 feet over 8 tracks near Kurla. You see, it's even now few of the uh, such portals remain, but now they are changing because the life is also finished. It's almost 100 years, and being in Bombay, it's a corrosion also. So these are extinct now. Slowly and slowly, they are being removed with better and higher strength mast. This is about the advertisement of the first railway electrification in India. The English Electric Company Limited has given this advertisement in the newspapers during that time. Again, it's a very ferocious looking locomotive, WCM5. This loco gives the impression of a beast. And whenever I used to see this locomotive in operation, I used to feel it gives a very, as if a lot of power is inside it. It's again WCM3, WAG5 with the PCN load. Minded it's a tramway type OHE, because during that time it was decided in RE to save cost, that all the loop lines should be having only a tramway type OHE, which will be saving the cost of the catenary. But now the things, after maybe after 10 years of this decision, the decision was reversed, and it was decided to have the normal OHE even on the loop lines. You see, both the loop lines are having only single contact wire. This was not very reliable also, and the flow of current was also less. But since that time the speed was less, the locomotives were less powerful, and perhaps the economy was more important, so it was decided. But then it was later changed. Now everything is made with. Now we are also going for higher cross section of catenary, higher cross section of contact wire, much better conductivity contact wires, even with a silver infusion, because now we are aware that current requirement is going to be higher and higher as the trains will increase the speed and the load. It's again a WM1 locomotive. It's a EMU coach. I'm 41, 20 minutes left. I'll be like to interact also. There's a WAP3 used to run Shatabdi locomotive, Shatabdi train between Delhi and initially Gwalior, then extended to Jhansi. It's an old map. It's EMU train photograph. It's perhaps Churchgate or VT. It's a buffer. Buffer. It's a hydraulic buffer, so that if a train doesn't stop, it can it comes up to this place, and this hydraulics stop the train, dampens the speed and the impact of the collision. It's a rotary converter, because initially, as I told, there was no electronics availability, so people only know to convert DC to AC and AC to DC via rotary converter. Like they should have two. It's a simpler thing that it should have two motors, one running as motor and one running as a generator, and then AC can be converted to DC and DC can be converted to AC by having coupled two motors. So this is a rotary converter. Again, a different Thomson Austin rotary converter, 15 kV mercury, and then the blue one is the mercury rectifiers. I am thankful to most of the fans, because these photographs I have taken from number of either internet or from our own fans, especially Mr. Kaushik, who I think he must be aware. I must thank him. He has given me a lot of photographs which I am it was very easy for me, because of lack of time. I didn't have so much of time. But these photographs, the courtesy is Mr. Kaushik. This is a mercury arc rectifier which could convert the AC to AC to DC without the rotary part. This again is photographs of. This is a Central Railway EMU. I'll speed up because there's no time left. Otherwise, we'll be having less interaction. This is ICF EMU. It's a GIP locomotive down below, and it's a comparison between the lower, this one is a photograph of a WCM5 and old CWD Canadian work class locomotive, which was imported during the Second World War to India, and it remained for a very long time. I have seen this running. It used to haul Tufan Express between Agra and Tundla, even in 70s. It's the Calcutta train. Background, there's a Howrah Bridge over there, 3000 volt DC. There's a Bombay VT train having double decker train. It must be either Singhad Express, or I don't know whether Deccan Queen was having a double decker train coaches anytime. And it's about the work of electrification. As you see, the work of electrification is not easy, is as tough as our gangmen. Like gangmen are working down below, and the TRD portion is even more difficult because they are very height. And when at that height, when you see downwards, it's not easy. It's very scary also. But these people are very brave and very experienced. They keep on working, and In some places, I have seen in initial electrification, people go on working upwards, and the train passes below with the diesel traction. Really, they they are worth saluting, and it's a WCG 2 locomotive. It's again a EMU, and it's a photo of a Vande Bharat, lovely photo. It's a progress of railway electrification. Indian Railway electrified 97.64. Today it's over 98.1. 98.1 is already electrified till today, and we'll be completing in all the 100% very soon, because there's some construction work is also going on. That's why reaching 100% becomes difficult. By the time we reach 100%, some line is further doubled, or for some line is further extended. So we are almost 98.1, 99, but few tracks which are newly laid, that again there's a new contract going on, so those will also be done, but very soon in this year we'll be completing 100%. That's the target. This much is the broad gauge electrified. By December 24, 12 zones of IR complete electrified: southeast, central, northern, northeastern, WCR, NCR, ECOR, central, eastern, KRCL, metro, SCR, ECR, all fully electrified. We are celebrating the 100 years of railway electrification. Number of places, there are a lot of functions going on. This is a photograph, one of the function, which has been done at the Arakonam shed, Southern Railway. This I have taken from the Indian Railway, from my Indian Railway magazine, February edition. Of course, this from the my article only. This is state-wise electrified network. This was up to 1st of January 25. That time at 97.06. Today it's 98.1. And by December 24, the 12 zones were fully electrified. And this is the progress of railway electrification up to 24. After 14, the electrification pace was accelerated like anything, and a lot of work was done in electrification front. So with this, I end my presentation. Jai Hind, and I like to interact. Now the house is open for interaction.
Thank you very much, Dr. Gupta. It was indeed a very comprehensive, very complete, and very detailed presentation of electrification over the Indian Railways over the last 100 years. It is indeed quite gratifying that today, in terms of percentage of electrification, India is perhaps the #1 country in the world.
Yes, it is #1.
What about countries like Switzerland?
It's a very small country. Of course, it's 100% electrified, maybe around 95% electrified. But it's a very small country. It's much smaller than our Bombay suburban also. So, if we see the track kilometers, there is no comparison of Indian Railways in any of in the entire world.
There are a number of comments regarding how good your presentation was. Sushil Singh writes, very well researched presentation, especially the photographs and their explanation that you gave based on your experience. He also says that this presentation relived old memories of his. Sumanko Thiru says that it is coincidental that this year also happens to be 25 years of the WAP7 locomotive. I mean, along with the 100 years of railway electrification, it is 25 years of the WAP7 loco. And he also says that was a great presentation and he likes the photographs. Kaushik Dharwadkar has asked one question. He says, why 25 kV? Why not 20 kV or 30 kV or something like that? Why 25?
Yes. It's only SNCF. The SNCF was doing 25 kV and some voltage has to be decided. So it was good because 25 is perhaps in metric system 100, 1/4 of the 100 is 25 and it's easier. So that's why 25 was decided. That is what I am aware. But I have few seniors also. They can throw more light on this.
Okay. Anyway, Kaushik Dharwadkar is perhaps the greatest exponent of electric traction maybe in the whole country. He says that he also has a ringtone of the WAP7 of the WCG2 locomotive.
Yes, and that's why I mentioned his name. I purposely mentioned his name in my presentation.
I have one question. We keep hearing of the electrification of the hill railways. Are there any plans to electrify, say, the Nilgiri Railway or the Kangra Valley Railway or the Kalka Shimla Railway?
No, there's no such plans because that's a UNESCO railways, and that will, I think, that is going to the beauty of and the entire the vista that you used to see from the entire mountains that will decrease. I mean, that is what I feel, and there is no use also. So I think that is there are no at present no plans for converting those lines.
In fact, as a rail enthusiast, I've always felt that we should not electrify the hill railways. Their beauty
That's
lies
right.
in the way they are.
Yes, because
And of
it's a
course, as we
different.
mentioned, they are UNESCO sites. If we make any major change, they might remove the the UNESCO World Heritage tag that they have.
That's right.
Another question: just like you have track renewals after say 40 years, when does OHE require renewal?
Yes, they require every equipment has a different lifespan, and we in few places we see the contact wire diameter that has been continuously monitored, especially near the starters when the train start near the stop signals. Those places are getting worn out very fast, so those are changed on a condition basis. Otherwise, after 50 years, the technology changes, so automatically we have to change because now it's better to go for silver without jointless contact wire, because now the with the new technology we have technology of having a jointless contact wires, and those can be having silver also in that, so that can give a better current and more reliable. So slowly and slowly 50 60 years is the life of the we are changing it depending on the age condition basis.
Are there any plans to go in for battery locomotives?
Yes, for like narrow gauge, yes, for a smaller operation and even for the shunting operation, we are going for hybrid locomotives. We are having hybrid tower wagons also, like that. Those can work in with Pento while going to the site, and when they reach the zone area, like working area, those can be changed to battery powered. So this will again eliminate the use of fossil fuel. So we are already in having hybrid tower cars, hybrid shunting locomotives, and small locomotives which are for less importance like narrow gauge and small haulage.
There's one more question from Shovan. He says, I have noticed the portion of the pantograph that touches the wire is different in case of DC and AC locomotives. What is the reason for that?
That is, yes. DC used to have double pan because you see it's a 1500-volt DC and 25,000 DC AC. So the current has to be almost more than 10 times, around 15, 16 times. So the same pantograph will not be having that much current collection as the uh, AC in case of DC. That's why you will always see the two pantographs, one is AC and DC in our WCAM series locomotive. There was one DC Pento, one AC Pento. DC Pento used to be slightly bulky, having two pens to correct more current, and the AC used to have less current. Incidentally, these were interchangeable in emergencies. The DC could be used in AC, AC could be used in DC, but only for certain time. Because suppose one pantograph is defective, the train cannot be stopped. So, of course, AC Pento can be used in DC application also, but with a reduced current application.
Sirish Paralte says, I think the mystery remains. I say this because HP voltages do not follow the logic explained by Doctor in the 50 kilohertz, only 50 hertz world. The high voltage voltages are 11, 22, 33, 66, 100, 132, 220, not multiples of fraction of 100.
Again, because the SNCF was French and these 1122, these are British standards.
Okay.
So I think but what is my gut feeling. I don't know how far I'll be. I am not an authority on this, but I feel because the traction was based on French technology, SNCF, so they were using 25, and this the normal current voltages of the state government, they used to follow the British this thing. That's why 11, 22, 33 that went all. I mean, that is
Yeah,
what
I think you're right, Dr. Gupta. I happen to have spent 4 years in Mali, not with the railways, but on doing some other work. And there I found that where we have 132 kV normal transmission voltage, they use 125. So the French have probably going for figures like 125, 25, and so on.
because
But see,
it's
in India
easier.
we have 132 kilovolts, whereas they had 125.
Yes, for metric system, like you see, when it was a ana was 12 paisa, ana, I think 12 ana, 10 ana, because that time the ana used to be there. Those used to be 12 multiples of 12. But then started the metric system. Then came the new rupees. It was 25 paisa, 50 paisa, 100 paisa. So perhaps that could be one of the reasons.
There's one last comment by Ajay Singh. What it says that with 70% power still based on fossil fuels in India, can we say that electric power is fully green?
Yes, we are going by 2030. There's a mandate from our Honorable Prime Minister that Indian Railways is going to be net zero carbon emitter by 2030. And we are working on this, and we are sure to achieve the target. Already we have had we are green energy, we are buying lot of solar energy, we are having our own wind power, REMCL, we have our own railway electric management company. We own around 23 wind turbines of 2 megawatt each in the Jaisalmer area. In east southern part, we have our own wind turbines. We have extreme solar cells. We are having PPA with our green and energy developers. Nuclear, yes, we are going for nuclear because nuclear is a clean energy. We are going for nuclear. We are tying up with the Nuclear Energy Corporation of India Limited. We plan to have our own captive nuclear power plant, and we want to have our own small modular reactors also. We are going for small modular reactor technology. We are working on it. We have great ambition in this region, and we'll be able to achieve the targets as per 2030. We'll be green, net zero carbon emitter.
Of course, personally, I feel that even if electricity today is not totally green, at least we are shifting it away from the urban centers and into some place which is outside the cities in power plants. At least that much
So,
we have
Mr.
achieved. We have shifted where the pollution is.
Anand sir wants to speak. I think he's raising his hands. He has been my boss and my inspiration, sir. Please, sir.
Okay, Mr. Anand, go ahead.
That was a very good presentation. You see, in the initial days of electrification, which was mostly in the continent, they tried different systems, 1500 volts DC, 3000 volts DC, and 11 kV at 16 and 2/3 cycle AC, but essentially it was a DC supply because of the low frequency. And Italy even tried 3-phase current collection. One phase from the overhead, there were two sort of pantographs, two parallel overhead lines, and one groundwork. Of course, it became hell at points and crossings, so they gave up that idea. It was a leap of faith for Indian Railways. We jumped into this with our eyes and ears wide open, and it was I should say, a leap of faith by the then railway administration. Incidentally, that leap was taken was suggested by a mechanical engineer by name P.N. Murthy, though he was an electrical engineer by training. And then, so it was essentially, the other point was that the high voltage tracks, high voltage lines, the public distribution system was at 132 kV mostly, and it followed the railway tracks. So that was another reason you could set up the but I think in fine, the greatest achievement of the Indian Railways was the conversion of the DC area in Bombay suburban, which was done very quietly, without much ado, without disrupting traffic. And till the whole system is 25 kV.
Yes.
That is
Sir, with now So I like to interrupt, sir, with now, since more power is required, so we are going for massive 2 into 25 kV. Now all our new OHE will be 2 into 25 kV. The OHE will remain the same, but there will be a feeder wire of minus 25 kV running along, so that in every point, the potential difference is going to be 2 into 25, that is 50 kV. So we'll have less of current, carrying capacity will be almost double, and voltage drop will almost be eliminated. So all our new trunk routes, we are going for 225 kV. With the work is going on in Delhi, Bombay, Delhi, Havana section already completed. OHE work is completed, and the traction substations also come up. Within a year, it is going to be 225 kV in both the trunk routes.
Anyway, thank you, Dr. Gupta. It is now time for the next talk, so we will end here. Thank you very much for a wonderful talk. It has enlightened, at least it has enlightened me a lot. Thank you very much.
Thank you, sir. Wonderful, sir. Wonderful to be with you also. Thank you.
Over to you, Manoj.